Hello guys and welcome to my new video. Today I want to talk about this Uni-t UT61E. Okay, we're gonna unbox it first. This is all that there is inside. It comes with user manual, a couple of CDs inside. We're gonna put this aside. Test leads, COM to USB adapter. That's really nice. And this is the COM interface, the serial interface for the multimeter, for connecting the multimeter to the computer. And of course, on one of these DVDs it also provides the software for connecting it to the computer. Basically, what's so cool about this multimeter is that it's supposed to have a computer recording function. So you are supposed to be able to connect it to the personal computer and to have some data recorded, and then be able to export that data into an Excel file and then run some analysis. We're gonna install the battery inside. This is how the battery compartment is looking like. I can tell you from the start that I don't really like that they don't really have a reverse polarity protection system here. I mean, you could connect the battery either way here. It says plus and minus there, but what if somebody connects the battery in reverse? I don't know. If you look on the other side of the on the lead, basically, you see that the battery is supposed to be inserted like this into the lead, and then take the lead and insert it into the multimeter. But the problem is that somebody might put the battery inside first and then try to put the lead. Now, if somebody is inserting the battery inside and they don't have the multimeter on, I would expect that nothing bad will happen. So they just have to figure out that the battery won't fit here in any other way, and if you try to put it in reverse here and then you try to put the lead won't fit. But from my point of view, this is, I don't know. I don't even know if the multimeter is getting wrecked or if it's something burning inside, if you actually manage to place the battery in reverse or not. I don't even know if it has like a rectifier on the board of the multimeter or some reverse polarity protection system with some MOSFETs. I just noticed this, so if you want to try to place it in reverse and see what happens, be my guest. I'm gonna put these aside. This is nice. It's supposed to be a 5-digit multimeter to provide a very accurate resolution. I'm going to try to position it in such a manner that it will provide best readings without reflecting the light. The test leads, first of all, let us check them. They seem to be pretty long, so like, I don't know, at least 1 meter. and they seem to be really thick. No compromise here. They withstand 1000 volts on ESD discharge. Okay, so a quick explanation about the multimeter. It seems like it has 4 connectors here for the test leads. Of course, the common, the volts, ohm, hertz, and capacitor symbols are displayed here. And for the other 2 holes, you have the milliamps, the microamps, and the amps, the 10 amp fused one. This is supposed to be a true RMS multimeter, so that's why we're gonna compare it today with my old 87.5 Fluke. And then it has voltage reading, alternating and continuous voltage reading, millivolt reading, both continuous and alternating. It has resistance measurement, diode tester, buzzer, capacimeter, frequency meter, microamps, milliamps, and amps. All these yellow functions here can be obtained by pressing the yellow button, and all the blue functions here can be obtained by pressing the blue button. So it also has the possibility of switching the ranges manually, but it also has the possibility of having the multimeter on automatic. It has maximum values, it has minimum values. I couldn't find any reference that this multimeter would have averages, would display averages. You have the relative button for zeroing the multimeter. If you want to go for very small values, like very small resistances, you want to measure some shunt resistors or something, then you could use the relative button to zero it, and then go for a more accurate reading. And of course you have the incrementing bar graph display here. The hold button, I couldn't find any reference whether or not it has backlight. And on the back side of the multimeter it comes with this port right here where you're supposed to insert these optocoupler probe or cable, and through this optocoupler to serial converter, and then through this serial to USB, you're supposed to feed the signal into the computer and have it recorded on the computer. I don't really know what it's doing now and why it's beeping like this. Anyways, first of all, we're gonna test out if the reading of the alternating voltage of this multimeter is at least as good as the reading of my calibrated 87.5, and draw some conclusions. I mounted a network of 10 resistors. This basically acts like a voltage divider here. So I have 10 resistors of 100 kilo ohm each, adding up to 1 mega ohm, and I only have the oscilloscope connected on one of the resistors, giving me a 1 divided by 10 reading. And I am using my oscilloscope right here to be able to monitor the waveform. As you can see, the voltage is not really a sign. It has these flat areas right here, and the waveform, if you zoom out, rather looks like being triangular. So it's an approximated waveform, it's not a pure sine. So having this in mind, we could go ahead and look at the reading of this meter, draw some conclusions about it. Okay, so first of all, we switch to alternating. It's on auto scaling, and now we could go ahead and connect it in parallel with the other multimeter I have and have some readout. This actually looks really good, but I don't know if you notice the shifting of the numbers here on the display of the unit meter. It's not happening as fast as on the fluke. So this means that the fluke has a way much faster microcontroller, and therefore it's able to read and interpret these voltages faster. But other than this, I would say that I'm really pleased with the readings of this UT61E multimeter, and it looks like it is really a true RMS multimeter, and this is a big plus from my side. Okay, let's move on to the resistance measurement function. It's on auto scale. From time to time it really does this, like the display is really flickering like this, and this is kind of annoying. I mean, if you have a poor contact or something, it seems like it's not as fast as the Fluke 87.5, but it doesn't filter out this flickering of the screen. So it seems like the resistance of the test leads here, it's like 160 milliohms. If I zero it out, I should be able to use this to measure some shunt resistors. Okay, for instance, I could measure right now the resistance of this steel wire, at least of a portion of it, and see that on this length I almost have 0.6 something ohms. As you can see, it's not really accurate, and I don't even know if this is happening because my surface contact is not really good or clean, or it's because of the processor of the multimeter. I don't really know what to say. For the next part, I would like to switch to the buzzer as usual and to see if it really has a continuous buzzing sound. Some people are really interested in this when they are testing a new multimeter. They are like, first of all, I need to hear the buzzer. if the buzzer doesn't sound good and it sounds like a very cheapish multimeter, then whenever I need to test the continuity of a cable and I will get some flickerings or interruptions or something like this, I won't know for sure if this is happening because of the internal circuitry of the multimeter, or it will happen because I have a poor contact I'm measuring, or there is an interrupted cable or something like this. So from this point of view, I would say this is medium. My guess is that the threshold for this buzzer is not set properly. Let's say below 20 ohms or something like this, I should be hearing the buzzing sound, but this multimeter has it set really low, I think. So whenever I have some contact problem on the surface of the tip of the probe, then I'm getting this interrupted sound. So from this point of view, I would say there is room for improvement here for the creators of this multimeter. Another function I would be really interested in testing out is the diode tester. A lot of multimeters cannot measure LEDs, cannot test LEDs. They have a very low voltage range on the diode tester function, like around 1.5 volts, and these 1.5 volts is not they are not enough to open the junction of an LED, so you are basically not able to test an LED. Let us see if this thing has it or not. It seems like I'm able to open the LED, but it's nothing displayed on screen, although I'm on manual right now. I wonder if I can switch on automatic. So I am on automatic right now, but if I switch to the diode tester, then it switches to manual, and when I'm trying to switch on automatic back, pressing the range button, it won't do anything. If I'm pressing the relative button, this doesn't do anything. See if this is displaying something on the screen. There you go. So it seems like if the LED's junction is opening up at 1.8 volts or something below 2 volts, I will get a reading on the screen. But if I have higher values, then it won't display anything. Let's come back to this one. No, nothing. So from this point of view, I would say I'm kind of disappointed about this. I mean, it's for the basics, you know. I need sometimes to measure a diode, an LED. Like, we're living in this digital world, and the backlights of computer monitors are made out of LEDs. Sometimes I need to test them. The backlight of LG monitors and TVs are composed of LEDs which are burning down, and we need to replace them. And sometimes I just need to go there and measure some LEDs and to see which one of them has a slightly lower value or a slightly higher value than the other ones, and to draw some conclusions there. And I'm paying something to buy a more expensive multimeter, and I can't do anything with it. I can't measure this function. So from this point of view, I would say this is a minus, and I really don't like it. Moving on to capacitors. I'm really curious about this, and as always, I'm interested in measuring SMD capacitors first of all. So I'm gonna take an SMD capacitor from here. This is supposed to be a 100 nanofarad capacitor. From this point of view, it's okay. Like I said before, I'm not really happy with these multimeters. They are measuring capacitors, but they won't say the internal resistance of the capacitor, of the electrolytic capacitor, and they will not display any other parameters. So for this, I would rather say that I'm more pleased with having something like this, the $5 capacitor tester. If I'm connecting an electrolytic capacitor here into this tester, it will automatically display the ESR of the capacitor. I don't know if you can see it. Yeah, here it will display the ESR of the capacitor, and it will also display the V loss percentage, and of course the value of the capacitor. So in my opinion, even this $5 tester, it's way much better than something like this when it comes to testing capacitors. And if I'm trying to measure an electrolytic capacitor using the capacimeter function of this multimeter, it will display only the microfarad value there. So this is a 100 microfarad 25 volt electrolytic capacitor, but it will not display the ESR, the equivalent series resistance of the capacitor. And when I'm fixing a computer monitor, or when I'm fixing some motherboard or some electronic device or something, you know very well that once every 6 years or once every 10 years or something like this, these capacitors are drying out. If you measure the capacitance of the component, it will show as probably what it's written on the case, but the parameter that it's modifying, it's basically the ESR of the capacitor. So if the ESR it's getting higher, then it's not filtering very well at certain frequencies, and then you have the problems starting to happen inside the motherboard. So this capacimeter function of the multimeter is basically, in my opinion, only for identifying capacitors. When you have some of them in a tray like this and you accidentally spill them, they have no marking on their case, and the only way to go is to go and identify them one by one, having a multimeter with the capacitor reading function. So from this point of view, I would say that I'm having a function here and I cannot really use it in my daily work. Moving on with the Hertz and duty cycle function right here, I went a little bit through the user manual, and this user manual was saying that this frequency meter, frequency counter, is basically allowing a peak-to-peak voltage of maximum 30 volts. Now if you are not skilled enough to understand this, and you think like this is an additional function for measuring Hertz or duty cycle for alternating voltages, and you are on the volt reading function, and you are with the test leads inside the PowerPoint in the wall, and at some point you decide, maybe I need to know the frequency of the grid or the duty cycle, and you accidentally, by mistake, rotate the switch through all these functions to reach to the Hertz and the duty cycle reading there, then you blow your meter and you will destroy this function, and while you are with the test leads in the PowerPoint on the wall there, and you switch through all these functions, chances are that you will destroy the microcontroller of the unit and it will be no longer usable. So I don't know what to say about this. It seems like a trap, and if you don't go and read through the user manual very carefully when you buy this unit, chances are that you are gonna blow it. On the other hand, if you want to read the frequency of the signal using this this function right here, you only need to press the yellow button once and it will display the frequency. By the way, this is picked up by the test leads. Probably it reads out a few millivolts because I have these wires here connected to the grid, so it is behaving as a capacitor right now and picking up this frequency through the air. And if I press it once more, it will display the duty cycle of the grid's voltage. So it doesn't say here that you are able to read the duty cycle, it only says Hertz. It would have helped, in my opinion, to have the percent sign here and to realize that, hey, I can go ahead and switch to duty cycle here, because if I want to measure the duty cycle of the grid's voltage and I have no idea that I don't have to switch to this function because I will blow the meter, then this is going to happen. So from this point of view, I think this is a mistake, and it's very misleading, and it can only lead to hazardous situations. And for the last part of the tutorial today, of the review, I am gonna connect this meter to the computer. I went ahead and installed the app. I can tell you about this app that it's a little picky. You can only select, for instance, between COM1, COM2, COM3 and COM4, and it won't let you have any other COM settings here. So for instance, I was having these USB ports on the left side here of my laptop, and one of them was assigned to COM6, the other one to COM5. I wasn't able to find them here in the list. I had to go to the device manager and set one of these ports to COM2, which was available. But what if you don't have an available and you do have internal USB connected devices on your machine? Then what do? You have to go and make some changes in your system there. This is a minus from my side. So if I click COM connect, I have a reading and it's looking really nice. I have to say that I never really afforded to have a recording multimeter. The cheapest option would probably be a Fluke 289 or something like this, and that's kind of expensive. It's at least $500 and something. If you want to go for buying it from eBay or something used, maybe it will be cheaper, but honestly I couldn't afford it. So I'm very happy to have a recording solution into this multimeter, and the interface, it's kind of looking really nice. So I'm just gonna switch to the millivolts function there because it's more sensitive and I can have the leads here in my hand. and when I touch them I can have some readouts here. Or you can basically, I expect that you can record all the values, all the functions here, and it will just display all the values in some charts here, and it will give you the unit, the value here, the function, and the sample number and the sample time, basically the time when the sample was taken. You could go and switch through different recording sheets, and although it doesn't say, I think these numbers here are representing the maximum numbers of samples. Like for instance, if I have the 10,000 selected right here, I will have a new sheet with only a maximum of 10,000 recordings. So when I reach 10,000 recordings, the sheet will just stop. I don't know. I would really need more information about this. I don't see any button with help, so I don't think it has like an electronic user manual for this application. I don't see any setting for, oh, I do see it now, the sampling interval. So theoretically I could go here and modify the sampling interval. So if I, for instance, have the sampling time set to 100, if this would work. So now it's working. This is really confusing. I don't know, when I was having the sampling interval box ticked in the beginning here, and I was having this value declared here, it wasn't doing anything. Then I unticked it and it was giving me samples as fast as the multimeter was able to record them or to measure them. And then when I ticked the box again to have the samples recorded by a certain interval, then it started sampling from 10 seconds to 10 seconds. So I don't really know what to say about this. It seems like having this app is a really good thing, and it's a very affordable way of having computer sampling multimeter. On the other hand, this multimeter, as you saw, has its drawbacks. You also have the possibility of setting the high limit here for the measurement and the low limit. So whenever your measurement exceeds these limits right here, you will have a fail error displayed here. So I guess this is a funny way of measuring data and of having some visual on what's happening there. Another thing I forgot to mention is it comes with this accessory, and this is basically for measuring the HFE factor of transistors. So you are supposed to connect the transistors right here and then connect this device here. First of all, I was surprised by the fact that the user manual mentions nothing about it, and then I don't see anything written on the meter like where is this actually connecting. And then I went online and it says that this thing can only be connected to the UT61A meter. So why do they provide it in the first place? If I'm not having any function on the rotary switch there to select something like this, if I don't have any writing like for the UT61A, there is an indication here that this thing would connect between this connector and this one. So they provide some unuseful accessories with the meter, and again I would rather use something like this for measuring transistors. Thank you very much for watching this video. I hope that you liked it. Don't forget to leave your comments in the comment section below, and of course to subscribe to this channel for more videos like this one.